Well, hello, fifth graders. This is just a Unit 6 retake test review. Many of the questions that will be on the test tomorrow will be gone through on this video here, so you can get a general idea what the test will look like. The test will look almost identical to what the first test you took. Now that you've had an opportunity to go back through, and I'm really encouraging you to go through the test with yourself or with your parent as well and look through the answers, the questions that you got incorrect, and say, what was the answer here, most of which I've written in, and what can I do next time to get the full credit? So that's what this video is meant to do, is to help you out so you're better prepared and you better understand the material. Okay, the first couple problems that we're going to work on are about adding and subtracting fractions with unlike denominators. We're going to look at three different problems here, two of which are similar in nature and one's a little bit different. Now, the first two problems are examples where I have two different denominators where two different problems where the denominators are different. Now, in both of these cases, I don't need to multiply by the opposite denominator. I don't need to multiply these numbers by 8 and these by 2. I can actually multiply 2 times something to get to 8. Right now, you're probably thinking to yourself, well, Mr. Weiner, you could times... Whoa, that's a big marker there. Why don't I erase that? We can multiply both of these by 4 because 2 times 4 is 8. Now I do the same thing to my numerator as I did to my denominator, and I rewrite the problem. That's one of the most important things, is that you rewrite the problem because you're able to show the steps that you took. Not only to receive potential partial credit if you make a mistake, but also because this helps you track along as well. What are the steps that I'm doing to solve this problem? I can solve this by adding the numerators together. Remember that denominator always stays the same. It always stays as an 8. Next up, we have 1/3 and 1/9. Well, for both of these problems here, well, I can take 3 times something to get to 9. 3 times 3 can get me to 9. Well, I multiply both my denominator and numerator by the same amount, because if I didn't do that, they wouldn't be equivalent fractions. So I rewrite my problem as 3 ninths plus 1/9, which is when I add together 4 ninths. Now let's look at the last problem. This one's a little bit different. This I can't do 7 times something to get to 10. So I need to multiply by the opposite denominators. So I need to multiply this fraction by 10. How do I know where that comes from? It comes from this denominator. It goes over there and there. And for my other fraction, I need to multiply by 7. I multiply these out, and I have 35 70ths plus 10 70ths. Now that equals 45 70ths. But however, I'm not done yet. I still have my 45 70ths, and I can make it smaller. I can reduce it. Now, the clues when I talk about reducing fractions, which will be our next topic, is when I look at these last numbers, there's some clues. Remember the rule of thumb? When you take your thumb and you put it right in your mouth, right behind your tooth. That means that we talked about that if you have an even number as your numerator and an even number as your denominator, you can divide both by 2. Both the numerator and denominator by 2 to help reduce it. In this case, 5 is not an even number, so it's not divisible by 2. But I see that they both end with a 5 and a 0, which gives me the clue that I can divide both of these numbers by 5. So I have 9, and then 70 divided by 5 is 14. Okay? Now I look at both these numbers and I say, can I divide both of these numbers by the same amount? Well, I think about the factors. The factors of 14, for example, are 1 and 14, 2 and 7, and those are the only factors, if you remember rainbow factors from the beginning of the year. Now, can I divide 9 by 2? No. Can I divide 9 by 7? No. And I can't divide 9 by 14. So this is as simple as it gets. This is our final answer. And we'll just put like a little star by it. Final answer there. Okay. 9/14 is as small as it can get. Oftentimes you'll see the smallest fraction is represented by one of the numbers as being prime. That's actually quite common that happens. Just a little clue for you. The next thing that we're going to go over is simplifying fractions. Now, in all 6 of these problems, we have 6 different fractions, and we can either reduce them or we can't. We're going to go over some strategies on how you know whether you can reduce it or not. Our first fraction, 5/10, we can divide both of these numbers by 5. The reason why I know that is because I know that numbers that end in 0 and 5 are both divisible by 5. They can be reduced to 1/2. Feel free to pause this video at any time and try them on your own and then check your work with me. That's another option too. Next up we have 10/16. Well, they're both even numbers, so I can divide by 2. I have left 5/8. Now, I know that 5 is a prime number, and almost every time that you see a prime number, it's as small as you can get it. So 5/8. Now you might be saying, well, 5/10, well 5 is prime, so why was it not the smallest? I said most of the time. So it's pretty much a good clue that you've gone as low as you can go. Always think about the factors of the number and see if you can make it any smaller based off the factors. The third one down is kind of tricky because they're actually both divisible by 3. If you found the factors of them, 3 would be a factor for both. And what you have left is you have, look at that, Mr. Weiner made a mistake. Even teachers make mistakes. Let's look at this right here. What are both numbers divisible by? They're both divisible by 7. If you're looking at thinking Mr. Weiner is losing it, it's because I am losing it. 21 divided by 7 is 3, and 28 divided by 7 is 4. Okay. We know that this is as simple as it can go. This is the prime number up top, 3, and it's in pretty small terms. So it's pretty clear that this is as small as it can be. Let's look at 40 120ths. I can divide both of these by 10. They both end in 0. That's a good clue for me. And I have 4/12 left. Well, both of these numbers are divisible by 4, so I can continue to make them smaller. Sometimes I think 5th graders think they can only do it once, but they can actually do it twice, if not many more times than that. And the last two are kind of trick questions, because these are actually already in simplest form. Sometimes you'll see fractions that are in simplest form. Actually, most of the time you'll see fractions that are in simplest form. This would just stay the same as 2/5. My key is my prime number. And this last one is, we call this a unit fraction, where a 1 is a numerator and the denominator is just any other number. Anytime you have a unit fraction, that's as small as it can go. Okay, the next topic that we need to talk about is quantitative and qualitative information. Now, as we talked about in class and you wrote in your notes, the N from quantitative stands for numbers, okay? That means you need to answer your response with numbers. Now, qualitative, the L stands for the language. So you're using words. Suppose I had a graph, and I'm just going to kind of draw a graph here. And we talked about the number of wins the Detroit Pistons had per game. Number of wins they had per season. So let's just measure 2012, 2013, 2014. Let's say, and they're actually not this good, but let's just say they are, just for our sake right now. Say in 2012 they had 40 wins. In 2013 they had 52. And in 2014 they had 60 wins, which is not really likely at all. But it helps us make our graph for right now. Now, some important things about this graph before I move on. This right here is the x-axis. The x-axis goes from side to side. Up and down, vertically, we have our y-axis. I'll write the y in. You can see for both of these that for this graph, they are labeled the x and y. Make sure that you do this when you make your own line or bar graph. Now, the labels, 2012, 2013, 2014, tell us what year it is. So we're just going to write the year. And 40, 50, and 60, that stands for games won. Now, on my iPad, it won't let me write all the way over. So typically you would write it over here, okay? You have Detroit and your title, Detroit games won. Okay. And this right here would be your label. Sorry about the color change there. So if we were to talk about a quantitative and qualitative observation, I'm going to write quan right here. Actually, I'll just write quantitative. For quantitative observation. This includes numbers. We might even say the max is 60 wins in 2014. Or I might say the range is 20 games won. you notice in both of these I have numbers. In this case I have 20, in this case I have 20 wins in 2014. Now if I were to talk about a qualitative, and I'm going to run out of room here, observation, I would say something along the lines of the Pistons won more games each year they played. Okay, that would be qualitative. It just uses words and describes what the graph shows here. It shows that the graph increases, that they won more games per year, but it doesn't necessarily say how many they won. That would be a qualitative response, different from quantitative. The key thing you need to remember is N stands for numbers, L stands for language. The last thing that you need to remember, and here we are on the new slide. The last thing that you need to remember is that you need to go over and memorize the fractions to decimals. Some key ones that you should know, and just an FYI, you should know that a half is 0.5, 50%. You should know that a third is 0.3 repeating, or 33.3% repeating. You should know a quarter is 0.25 or 25%. 1/10 is 0.1 or 10%. 1/100th is 0.01 or 1%. Okay. The last one that I'll add in is 1/5. You should know that that is. Oh, I'm sorry. There's two more. I hate to keep throwing more at you, but you really need to know these, which is 0.2 or 20%. And the last but not least is 2/3, which is 0.66 repeating, or 66.6%. Okay, so those are the ones. This is a little sloppy on the last page, but this is the information you need to know. So have somebody test you these information. It would be probably easier for you to just use the handout that I use. These 1, 2, 3, 4, 5, 6, 7, and I'm not going to tell you for sure that there are 4 of them on the retake, but I would be pretty certain that you will find 4 of these on the retake tomorrow. So if you have any questions, email me. My email is the following: kwayner@kcsa.org, or you can call me. That doesn't bother me if you call me, 616-212-7413. Thanks so much, and have a great night.